German tank crews never expected the U.S. Hellcat to hit 55 miles per hour. September 24, Lorraine, France. German Oberfeldwebel Karl-Heinz Prinz peered through morning fog, expecting another slow, grinding tank duel. His Panzer IV carried 80 millimeters of frontal armor and decades of tactical doctrine. What he faced instead changed everything. American Sergeant Charles B. Hall sat inside an M18 Hellcat, its Wright Continental radial engine humming with enough power to outrun any German tank on the battlefield. While Prince's crew prepared for static warfare, Hall's machine could strike and vanish before German turrets could even turn. The Americans had built something impossible. A tank destroyer, faster than most trucks, armed with a gun that could penetrate German armor at distances Prince thought safe. But speed was just the beginning. Behind every Hellcat stood Detroit factories producing armor faster than Germany could replace losses. How did American democracy's assembly lines render German military tradition obsolete? What happens when industrial might meets battlefield innovation? Before we get into the story, comment below where in the world you are watching from today. Gray fog clung to hedgerows and churned earth, muffling the rumble of Panzer IV engines across the Lorraine countryside. Diesel fumes mixed with the sharp tang of gunpowder that had saturated the soil for weeks. Oberfeldwebel Karl-Heinz Prinz hunched in his turret, checking fuel gauges with the obsessive care of a man who knew every drop mattered. His crew had received half rations of ammunition that morning. Every shell was calculated, every decision weighed against dwindling supplies. The morning air carried sounds Prince recognized: the deep growl of German engines, the squeak of bogie wheels on muddy tracks, radio-static crackling with coded positions. These were familiar rhythms of armored warfare, unchanged since the great victories in Poland and France. His Panzer IV had served faithfully across 3 campaigns, its 80 millimeter frontal armor deflecting enemy rounds, its 75 millimeter gun finding targets at respectable ranges. But something else moved through the mist. A different engine note, higher-pitched, more urgent. American voices on intercepted radio frequencies spoke of positions that changed too quickly for German doctrine to comprehend. Sergeant Charles B. Hall gripped the commander's periscope of his M18 Hellcat, feeling the Wright Continental R975 radial engine vibrate through the turret basket beneath him. 9 cylinders arranged in radial configuration produced 400 horsepower, pushing his 18-ton machine across mud-churned fields at speeds that defied German expectations. The engine's distinctive sound carried across the battlefield like a war cry. Hall's crew had trained for mobility warfare at Fort Hood, learning to exploit terrain features German tankers considered impassable. Their Hellcat could reach 55 miles per hour on roads, 35 across country. German Panzer IVs struggled to maintain 20 miles per hour under ideal conditions. The mathematics of warfare had shifted. German doctrine assumed static duels between armored vehicles, commanders selecting positions for extended engagements. American tank destroyers operated on different principles: strike fast, retreat faster, survive to strike again. Hall's 76 millimeter M1A2 gun could penetrate German armor at ranges exceeding 2,000 meters. More importantly, his crew could fire, displace, and occupy new firing positions before German turrets completed their traverse. German fuel reserves in September 1944 had fallen below 25% of 1941 levels. Each Panzer IV carried 470 liters of fuel, enough for 160 kilometers under combat conditions. Fuel shortages limited German ability to maneuver, forcing commanders to husband resources for defensive operations. Prince heard the roar again, closer now. Moving with impossible speed through terrain, his maps marked as impassable for armored vehicles. Sparks showered across the Detroit Arsenal tank plant floor, each arc illuminating workers bent over assembly stations. The crash of pneumatic hammers against steel plates created a percussion that could be felt in bones. Molten metal glowed orange in casting furnaces, while riveters, their hearing already damaged by months of industrial noise, shaped armor plates with methodical precision. Clara Bryant Ford tightened suspension bolts on a newly completed Hellcat, her hands blackened with oil and metal filings. The Wright Continental radial engine had been installed that morning, its cylinders still warm from testing. Each tank destroyer represented 200 hours of skilled labor, coordinated across 17 different production facilities. By September 1944, American factories had produced over 2,500 M18 Hellcats in 18 months. The Buick division of General Motors had designed the vehicle in record time, moving from initial specifications to production models in less than 2 years. German tank development programs required 3 to 4 years from concept to battlefield deployment. The factory floor stretched beyond sight, assembly lines moving with mechanical precision. Women comprised 40% of the workforce, filling positions vacated by men shipped overseas. Clara had joined the production line in 1942, learning to operate machinery that had previously been considered too complex for female workers. Her earnings supported 3 children and contributed to war bond purchases that financed the expanding military production Americans. Armored vehicle production in 1944 exceeded German totals by ratios that defied European understanding of industrial capacity. Detroit factories alone produced more tanks per month than all German manufacturing facilities combined. The arsenal of democracy operated 3 shifts daily, 7 days weekly, with production rates accelerating despite component shortages. Each Hellcat carried standardized components manufactured across multiple facilities. Engines came from Continental Motors in Muskegon, Michigan. Transmissions were assembled in Toledo, Ohio. Main guns were forged at Waterfleet Arsenal in New York. This distributed production system ensured that bombing campaigns could not halt. American tank destroyer manufacturing. Technical specifications reflected American industrial philosophy. Adequate performance produced in overwhelming quantities. The M18's armor ranged from 12 to 25 millimeters, sufficient to deflect small arms fire and shell fragments, but vulnerable to direct hits from anti-tank weapons. American designers prioritized speed and mechanical reliability over survivability, calculating that mobility provided better protection than static armor. German Panzer IV production in 1944 averaged 300 units monthly across all manufacturing facilities. Each tank required specialized components produced in limited quantities at vulnerable factory complexes. Allied bombing campaigns had reduced German tank production by 60% since 1943, forcing manufacturers to relocate equipment to dispersed workshops that could not achieve previous output levels. Clara wiped perspiration from her forehead, leaving a smear of oil across her skin. Another telegram had arrived yesterday, informing her neighbor that her son had been killed in France. The war's cost measured in more than production statistics. The assembly line carried another completed Hellcat toward the shipping dock, where railroad cars waited to transport it toward East Coast ports. Within 3 weeks, this particular tank destroyer would be unloaded at Cherbourg and assigned to the 704th Tank Destroyer Battalion. Clara pressed her palm against the warm steel, thinking of unknown soldiers who would drive her work into battle against enemies who could not match American productive capacity. General George S. Patton studied maps spread across tables illuminated by kerosene lanterns, their flames casting dancing shadows across pencil lines marking enemy positions. The Third Army command post occupied a requisitioned French farmhouse, its windows covered with blackout curtains that muffled the distant sound of artillery. Cigar smoke curled toward the ceiling, mixing with the smell of wet uniforms and coffee brewed from grounds used twice. The Lorraine campaign demanded tactical innovations that challenged conventional armored warfare doctrine. German forces had established defensive positions anchored on heavy tanks positioned for long-range engagements. American forces needed mobility to exploit gaps in enemy lines, striking before German crews could coordinate defensive fires. Patton's tactical philosophy emphasized speed over mass, maneuver over attrition. His armored divisions had demonstrated this approach during the breakout from Normandy, advancing faster than German commanders thought possible. Tank destroyers would spearhead attacks against enemy armor, their speed compensating for lighter armor protection. Sergeant Charles B. Hall awaited orders at his Hellcat, parked between stone walls that provided concealment from German observation. His crew had spent the morning checking mechanical systems, cleaning the 76mm gun bore, and reviewing radio frequencies for the coming engagement. The 704th Tank Destroyer Battalion had arrived in France 3 weeks earlier, their vehicles transported aboard Liberty ships that had crossed the Atlantic in convoy formation. Hall's military experience included training at Fort Hood, where American tank destroyer doctrine had been developed through extensive field exercises. Crews learned to coordinate with infantry units, provide covering fire during advances, and exploit terrain features for tactical advantage. The emphasis on mobility warfare contrasted sharply with European armored traditions that favored heavily armored vehicles in static positions. The M18 Hellcat represented American industrial capacity applied to battlefield requirements. Its Wright Continental radial engine produced sufficient power to maintain high speeds across varied terrain. The open turret design reduced weight while providing superior visibility for crew members. Main gun performance exceeded that of most German tank weapons, capable of penetrating enemy armor at ranges exceeding effective return fire distances. American tank destroyer units had trained extensively in rapid deployment tactics. Crews could occupy firing positions, engage targets, and displace to alternate positions within minutes. This tactical mobility exploited weaknesses in German defensive planning, which assumed enemy forces would remain stationary during engagements. Radio communication systems enabled coordination between multiple tank destroyers, creating overlapping fields of fire that covered extensive frontages. German armor units faced simultaneous attacks from multiple directions, preventing commanders from concentrating defensive fires effectively. Patton reviewed intelligence reports indicating German fuel shortages that limited enemy mobility. American forces could exploit this tactical advantage through sustained operations that exhausted German reserves. Tank destroyers would maintain pressure on enemy positions, forcing German commanders to expend precious fuel reserves repositioning defensive forces. Third Army logistics provided ammunition resupply, mechanical support, and fuel distribution that sustained operations far from base areas. American industrial production ensured adequate spare parts availability, mechanical reliability, and crew replacement systems. Patton's finger stabbed the map at Ericourt, where German armor had concentrated for counterattack operations. Send them forward. Engine roars answered across the assembly area as Hellcat crews started their vehicles, preparing to demonstrate American industrial might translated into battlefield supremacy. Rain-slicked fields into treacherous mud that grabbed at tank tracks and tested mechanical systems. Pushed beyond normal operating parameters, Hall's Hellcat moved through terrain that German commanders had dismissed as impassable for armored vehicles. Its suspension absorbing impacts from hidden obstacles and shell craters filled with stagnant water. The morning's first engagement occurred at ranges that violated German tactical assumptions. Hall's gunner acquired targets through his telescopic sight, identifying German Panzer IVs positioned for long-range duels. The 76mm M1A2 gun fired armor-piercing rounds that penetrated German frontal armor at distances exceeding 2,000 meters. German crews reacted with mechanical precision, drilled through years of training. Turrets traversed toward American positions, main guns elevated to engage detected targets. But Hall's Hellcat had already displaced, its powerful engine propelling the vehicle to alternate positions before German return fire could arrive. The 704th Tank Destroyer Battalion coordinated attacks across a frontage that stretched German defensive capabilities beyond effective limits. Multiple Hellcats engaged from concealed positions, creating crossfires that prevented German tanks from concentrating defensive fires. Radio communication enabled a tactical coordination that German commanders could not match with their cumbersome communication systems. Oberfeldwebel Karl-Heinz Prinz watched his unit absorb casualties that could not be replaced. German tank production had fallen to levels that made each loss strategically significant. His Panzer IV had served faithfully across multiple campaigns, but German industrial capacity could not provide replacement vehicles at rates matching American production. The 704th and 705th tank destroyer battalions destroyed over 250 German armored vehicles during 2 weeks of sustained operations, suffering losses totaling fewer than 50 American vehicles. This exchange ratio reflected tactical advantages created by American industrial supremacy and doctrinal innovations that exploited German weaknesses, German fuel shortages, compounded tactical disadvantages by limiting mobility options. Panzer IV fuel consumption averaged 2.4 liters per kilometer under combat conditions. German reserves could not sustain prolonged maneuver operations, forcing commanders to husband fuel for defensive operations that American tactics rendered ineffective. Hall's crew had perfected engagement procedures through extensive training and combat experience. Target acquisition, gun laying, firing sequence, and displacement required less than 3 minutes from initial detection to movement toward alternate positions. German crews needed 5 to 7 minutes for equivalent sequences, creating tactical windows that American forces exploited systematically. American ammunition resupply systems maintained adequate shell availability despite intensive combat operations. Each Hellcat carried 45 rounds of 76mm ammunition, with resupply convoys providing replacement stocks within hours of requests. German units often rationed ammunition, limiting crews to predetermined numbers of rounds per engagement. The battlefield demonstrated mathematical realities that German military doctrine had not anticipated. American industrial capacity produced replacement vehicles faster than German forces could destroy them. Tank destroyer losses were replaced within days, while German tank losses represented permanent reductions in combat capability. Smoke rose from burning German vehicles scattered across fields that had witnessed centuries of European warfare. This engagement differed from historical precedents through the application of American industrial might translated into tactical advantage. Flames licked the hillside, where a disabled Panther tank smoldered, its crew evacuated to avoid ammunition explosions. Hall's Hellcat had already vanished into morning mist, moving toward the next engagement with mechanical reliability that German opponents could not match. Karl-Heinz Prinz's Panzer IV rocked from recoil as its 75mm gun fired at targets that refused to remain stationary. Smoke stung his eyes, while the deafening blast inside the turret left his ears ringing with persistent tones that would last for days. His crew scrambled to reload, but their targets had vanished again, moving with speeds that violated every tactical principle Prinz had learned. German armored warfare doctrine emphasized methodical engagements between static positions. Commanders selected terrain features that provided cover and fields of fire, positioning tanks for sustained duels that exploited superior German gunnery training and mechanical reliability. Tank versus tank combat required patience, precision, and careful ammunition conservation. American tank destroyers operated according to different tactical principles that rendered German training ineffective. They struck without warning, fired accurate shots at maximum range, and withdrew before German crews could respond effectively. This mobility warfare created psychological pressure that German commanders struggled to address through conventional tactics. Prinz's unit had suffered 30% casualties during the first week of operations around Ericourt. Each loss represented years of crew training and irreplaceable mechanical systems that German industry could not replace rapidly. His remaining tanks operated with skeleton crews, combining survivors from destroyed vehicles into composite units with reduced combat effectiveness. German fuel shortages limited tactical options available to tank commanders. Panzer IV consumption rates averaged 140 liters per 100 kilometers under combat conditions. Available fuel reserves restricted movement to essential operations, preventing commanders from repositioning forces to counter American mobility tactics. Panther tank fuel consumption exceeded 2 gallons per kilometer, making these advanced vehicles strategic burdens rather than tactical assets. German commanders faced impossible choices between conserving fuel and maintaining combat effectiveness. Many Panther tanks remained immobilized in defensive positions, unable to exploit their superior gunnery and armor protection. Radio intercepts revealed American coordination systems that enabled multiple tank destroyers to concentrate fires against individual German targets. American crews communicated target locations, coordinated attack sequences, and shared intelligence about German positions with efficiency that German forces could not match. Synthetic fuel production had collapsed under Allied bombing campaigns that targeted chemical plants and transportation networks. Remaining fuel stocks were rationed among competing military requirements, with tank units receiving insufficient allocations to maintain operational tempo. American forces exploited these logistical weaknesses through sustained operations that exhausted German reserves. The psychological impact of American mobility tactics affected German crew performance in ways that training could not address. Soldiers accustomed to methodical, deliberate combat found themselves unable to engage targets that appeared and disappeared with supernatural speed. Traditional German advantages in training and equipment became irrelevant against opponents who refused to fight conventional battles. Prinz observed American tactics through his periscope, studying enemy movement patterns that defied logical explanation. These tank destroyers moved across terrain at speeds approaching those of wheeled vehicles, their tracks maintaining traction in conditions that would immobilize German tanks. German after-action reports described American forces as phantoms and ghosts, terminology that reflected psychological impact rather than tactical analysis. Crew morale deteriorated as losses mounted without corresponding damage to American forces, Prinz muttered through clenched teeth, his voice barely audible over engine noise and radio static. They fight like phantoms, appearing where they should not be, vanishing when we attempt to respond. Back in Detroit, assembly lines continued their relentless production rhythm while Clara Bryant Ford supervised engine testing procedures on newly completed Hellcats. Each Wright Continental radial engine underwent standardized performance evaluations that measured horsepower output, fuel consumption rates, and mechanical reliability under simulated combat conditions. Quality control systems ensured that American tank destroyers reached European battlefields with mechanical systems capable of sustained operations. German tank production occurred in dispersed workshops that lacked standardized testing equipment or quality control procedures. Allied bombing campaigns had forced manufacturers to relocate critical operations to facilities that could not duplicate previous production standards. German tanks reached frontline units with mechanical problems that reduced combat effectiveness and increased maintenance requirements. American industrial philosophy emphasized mass production of adequately performing equipment rather than small quantities of technically superior vehicles. This approach enabled rapid replacement of combat losses while maintaining consistent performance standards across large numbers of vehicles. German emphasis on technical excellence produced superior individual tanks that could not be manufactured in quantities sufficient to affect strategic outcomes. Liberty ships delivered replacement engines, transmission assemblies, and complete tank destroyers to European ports at rates exceeding German industrial capacity. Each convoy carried sufficient spare parts to maintain entire armored divisions, ensuring that American forces could sustain operations despite combat losses and mechanical failures. German logistics systems struggled to provide basic maintenance supplies to frontline units. Spare parts shortages forced crews to cannibalize disabled vehicles, reducing the number of operational tanks available for combat operations. Many German tanks sat immobilized awaiting repairs that could not be completed due to component shortages. Clara reviewed production schedules that called for increased Hellcat manufacturing to support expanding American operations in Europe and the Pacific Theater. Detroit factories operated at maximum capacity with additional production lines under construction to meet military requirements. Workers labored through extended shifts, their efforts directly supporting soldiers fighting thousands of miles from American industrial centers. By 1944, American armored vehicle production exceeded German totals by ratios approaching 3-to-1. The United States produced approximately 29,000 armored fighting vehicles annually, while Germany managed fewer than 17,000 vehicles of all types. This production differential created insurmountable strategic advantages that German tactical excellence could not overcome. German tank crews learned to husband ammunition, fuel, and mechanical systems with obsessive care because replacement supplies might not arrive for weeks. American crews operated with abundance mentalities, expending ammunition freely and requesting mechanical support without concern for strategic shortages. Factory workers across the American industrial base understood their direct connection to battlefield success. Each rivet, bolt, and mechanical component represented contributions to victory over enemies who could not match American productive capacity. This understanding motivated sustained effort despite difficult working conditions and personal sacrifices. Telling and preparing this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Clara watched another completed Hellcat roll toward the shipping dock, its olive drab paint still wet from application. Railroad cars waited to transport this particular tank destroyer eastward, beginning a journey that would end in European battlefields where American industrial might confronted German military tradition. The mathematics of warfare had shifted decisively in America's favor. For every tank destroyer lost in combat, American factories could produce replacements faster than German industry could manufacture new vehicles. Morning fog lifted across. Lorraine, as Patton's Third Army, resumed offensive operations designed to exploit German weaknesses through coordinated mobility warfare. Hall's Hellcat battalion spearheaded attacks against enemy positions, their speed enabling rapid penetration of defensive lines that German commanders had considered impregnable. Radio coordination enabled American tank destroyers to concentrate fires against individual German targets while maintaining tactical dispersion that prevented effective counter-battery fires. Multiple Hellcats could engage a single German tank from different directions simultaneously, creating crossfires that German crews could not counter effectively. American infantry advanced under covering fire provided by mobile tank destroyers that maintained overwatch positions throughout assault operations. This tactical coordination exploited German defensive planning that assumed static engagement patterns between opposing armored forces. Infantry units could maneuver freely while tank destroyers provided responsive fire support against emerging threats. Patton's tactical philosophy emphasized continuous pressure against enemy positions through sustained operations that exhausted German fuel and ammunition reserves. American logistics systems could maintain this operational tempo indefinitely, while German forces faced critical shortages that limited defensive options. Third Army advanced 60 miles during 2 weeks of intensive combat, despite German resistance anchored on prepared positions and in natural terrain obstacles. Tank destroyer units enabled this rapid advance through their ability to neutralize German armor threats while maintaining mobility necessary for exploitation. Operations American mechanics established forward repair facilities that could restore damaged Hellcats to operational status within hours of receiving battle damage. This maintenance capability multiplied effective tank destroyer strength by reducing time individual vehicles spent in non-operational status. German repair facilities could not match American maintenance efficiency due to spare parts shortages and limited technical support. German commanders reported psychological effects of continuous American pressure that prevented rest and reorganization, essential for effective defensive operations. Tank destroyer attacks occurred at random intervals throughout day and night periods, creating stress that reduced German crew performance and decision-making capabilities. American ammunition resupply systems delivered shells, fuel, and maintenance supplies to forward positions faster than German logistics could provide defensive materials. This logistical advantage enabled sustained American operations, while German forces conserved resources for critical defensive situations. The tactical coordination between American tank destroyers and supporting arms created combined arms effects that German forces could not match with available resources. Artillery fire suppressed German positions while tank destroyers exploited, resulting confusion to advance rapidly and engage targets before German crews could respond effectively. American air support provided additional tactical advantages through reconnaissance flights that identified German positions and close air support that disrupted enemy movements. German forces operated without effective air cover, making daylight movement extremely hazardous and limiting tactical options. Patton wrote in his personal diary that evening, documenting tactical lessons learned during the day's operations. Mobility wins battles, but logistics win wars. American industrial capacity provides both advantages simultaneously, creating insurmountable strategic superiority over enemies who cannot match our productive capability. Tank destroyer crews prepared for continued operations, their confidence boosted by mechanical reliability and tactical success against German opponents who could not adapt to American mobility warfare doctrine. French villagers huddled in stone cellars while artillery shells exploded overhead, their impacts shaking centuries-old foundations and sending plaster cascading from cracked ceilings. The smell of cordite mixed with dust from collapsed masonry and bread from bakeries. Abandoned when combat engagements swept through their community's liberation, arrived at 55 miles per hour as American tank. Destroyers thundered through village streets, their tracks grinding against cobblestones worn smooth by generations of peaceful commerce. Children pressed faces against cellar windows, watching olive-drab vehicles that moved faster than any German tank they had observed during 4 years of occupation. Hall's Hellcat crew distributed chocolate bars and cigarettes to French civilians who emerged cautiously from hiding places, their gratitude expressed through tears and embraces that transcended language barriers. American soldiers represented freedom from German oppression, but their arrival also brought destruction that would require years to repair. German reprisals against suspected collaborators had created terror that influenced civilian behavior. Throughout occupied territories, French communities faced impossible choices between resistance activities that risked collective punishment and cooperation that enabled German military operations. American liberation offered hope, but could not immediately heal psychological wounds inflicted during years of occupation. Civilian casualties from combat operations numbered in thousands as opposing armies fought through populated areas. Artillery fire could not discriminate between military targets and civilian structures, destroying homes, schools, and businesses that represented decades of community development. Liberation carried costs measured in more than military casualties. Nearly 2 million French civilians had been displaced during 1944 campaigns as combat operations swept across populated regions. Refugee movements created humanitarian crises that strained resources of liberation forces attempting to provide basic necessities while maintaining military operations against retreating German forces. American medical personnel treated civilian casualties alongside military wounded, their field hospitals overwhelmed by trauma cases that required immediate surgical intervention. French civilians suffered from malnutrition, disease, and injuries that reflected years of inadequate medical care under German occupation. Supply convoys carried humanitarian supplies alongside military equipment, demonstrating American commitment to civilian welfare during liberation operations. Food, medical supplies, and clothing reached displaced populations through logistical networks designed primarily for military support but adapted to address civilian requirements. French resistance fighters provided intelligence about German positions and movements, their local knowledge enabling American forces to navigate terrain features and avoid defensive strongpoints. This collaboration created tactical advantages that accelerated liberation operations while reducing American casualties. Village priests documented civilian experiences during German occupation and American liberation. their records providing historical testimony about warfare's impact on non-combatant populations. These accounts revealed psychological trauma that would influence French communities for generations beyond military victory. German forces retreated through populated areas, destroying infrastructure that would be necessary for post-war reconstruction. Bridges, power plants, and transportation networks suffered deliberate sabotage designed to impede American advance and complicate liberation efforts. A small child emerged from rubble-filled cellar, clutching a torn doll while staring at Hall's Hellcat with mixture of fear and curiosity. Liberation meant safety from German terror, but the thunder of American armor represented violence that would shape childhood memories forever. Freedom rolled forward at mechanical speed, its arrival both celebrated and mourned by civilian populations. Caught between opposing armies, Cherbourg, harbor filled with Liberty ships discharging cargo that represented American industrial capacity applied to global warfare. Cranes lifted crates containing replacement engines, transmission assemblies, ammunition, and complete tank destroyers, while stevedores worked around-the-clock schedules to maintain supply flows. Essential for continued operations, each Liberty ship carried sufficient military equipment to outfit entire armored battalions, their cargo capacity exceeding total German production for equivalent time periods. American shipbuilding programs had produced vessels faster than German submarines could sink them, ensuring reliable supply lines across Atlantic distances that German forces could not interdict effectively. Supply trains departed Cherbourg hourly, carrying American military equipment toward frontline units engaged in combat operations throughout France and approaching German borders. This logistical network could sustain operations at distances exceeding 1,000 kilometers from base ports, demonstrating strategic reach that German logistics could not match American. Industrial production in 1944 reached levels that exceeded German capabilities by margins, approaching 4-to-1 in critical categories. Tank destroyer manufacturing alone surpassed total German armored vehicle production, while American facilities also produced trucks, artillery, aircraft, and naval vessels in unprecedented quantities. German synthetic fuel production had collapsed under Allied bombing campaigns that targeted chemical plants essential for military operations. Remaining fuel stocks were insufficient to support sustained defensive operations, forcing German commanders to ration fuel allocations among competing military requirements. Liberty ships delivered 15 million tons of military supplies during 1944, representing productive capacity that German industry could not approach despite mobilization efforts that included forced labor from occupied territories. This logistical advantage enabled American forces to maintain operational tempo while German forces conserved resources for critical defensive situations. German tank crews learned to scavenge fuel, ammunition, and spare parts from disabled vehicles because replacement supplies might not arrive for weeks. American crews operated with abundance mentalities, requesting mechanical support and ammunition resupply without concern for strategic shortages that influenced every German decision. Allied bombing campaigns had reduced German industrial capacity by percentages exceeding 60% in critical production categories. Tank manufacturing, aircraft production, and chemical plants operated at fractions of pre-war output levels, creating strategic shortages that could not be addressed through tactical excellence. American production lines operated continuously, with factory workers understanding their direct contribution to military success. Each completed tank destroyer represented industrial capacity applied to tactical requirements, translating productive advantage into battlefield superiority over enemies who could not match American manufacturing capabilities. Port facilities at Cherbourg handled cargo volumes exceeding pre-war commercial traffic by factors of 10. Their capacity expanded through American engineering efforts that created military logistics networks capable of supporting million-man armies at continental distances from base. Areas, German logistics systems struggled to move limited supplies across transportation. networks damaged by Allied bombing and sabotage operations. Railroad lines, bridges, and fuel distribution systems operated at reduced capacity, creating bottlenecks that limited German tactical options. Mathematical reality dominated strategic planning. For every German tank destroyed, replacement time measured in months. For every American tank destroyer lost, replacement time measured in days. Industrial capacity determined strategic outcomes more decisively than tactical skill or technological advantage. Smoke drifted across. Haricourt battlefield where twisted steel testified to mathematical realities of modern warfare. German tank hulks scattered among shell craters represented tactical excellence, defeated by strategic abundance. Their crews' skill insufficient to overcome American industrial advantages. Third Army intelligence officers compiled casualty reports that documented German losses exceeding all previous engagements in Lorraine. 648 German tanks had been destroyed during September and October operations, with American tank destroyers responsible for approximately 40% of confirmed kills. American losses totaled fewer than 100 armored vehicles during equivalent time periods, creating exchange ratios that reflected tactical and strategic advantages working in combination. German commanders could not sustain operations that consumed irreplaceable equipment at rates exceeding industrial replacement capabilities. Battlefield salvage teams recovered usable components from destroyed German vehicles, their efforts revealing mechanical deficiencies that reflected resource shortages affecting German production. Steel quality had deteriorated, mechanical systems showed signs of substandard manufacturing, and ammunition performance indicated shortages of critical materials. German prisoners provided intelligence about fuel rationing that limited tactical mobility essential for effective defensive operations. Panzer units received fuel allocations sufficient for limited movement, forcing commanders to husband resources for critical situations rather than conducting aggressive defensive maneuvers. American mechanics established field repair facilities that could restore battle-damaged tank destroyers to operational status within hours of receiving combat damage. This maintenance capability multiplied effective strength by reducing time individual vehicles spent in non-operational status due to mechanical problems or battle damage. Statistical analysis revealed that German tactical doctrine had failed to adapt to American mobility warfare that exploited speed, advantages unavailable to heavily armored German tanks. Traditional European armored warfare emphasized static duels between vehicles positioned for extended engagements, but American forces refused to fight conventional battles. Radio intercepts indicated German command confusion about American tactical methods that violated established armored warfare principles. German officers reported enemy movements at speeds they considered impossible for tracked vehicles, describing American tank destroyers as supernatural rather than mechanical phenomena. German fuel consumption rates for Panzer IV and Panther tanks exceeded American Hellcat requirements by ratios approaching 2-to-1, creating tactical disadvantages that could not be overcome through superior gunnery or armor protection. American vehicles could maintain operations while German tanks remained immobilized due to fuel shortages. Prisoner interrogations revealed psychological impact of American industrial superiority on German crew morale. Soldiers understood that their equipment could not be replaced while American forces operated with seemingly unlimited resources, creating defeatist attitudes that reduced combat effectiveness independent of tactical situations. Medical evacuation statistics and demonstrated that American tank destroyer crews suffered lower casualty rates than German tank crews, despite engaging in more aggressive combat operations. Mobility provided better protection than static armor, confirming American tactical doctrine that emphasized speed over defensive strength. The battlefield mathematics were inescapable. American productive capacity had translated directly into tactical superiority that German military excellence could not overcome. Numbers told the complete story without requiring tactical analysis or strategic interpretation. Clara Bryant. Ford received news of Third Army victories through radio broadcasts that described tank destroyer successes in Lorraine, her factory floor erupting in cheers that echoed across assembly stations where workers understood their direct contribution to battlefield achievements. Each rivet, bolt, and mechanical component they had, assembled now participated in combat operations, thousands of miles from Detroit production facilities, war bond rallies, celebrated American industrial achievements that translated productive capacity into military victory over enemies who could not match democratic manufacturing capabilities. Workers contributed portions of wages to military financing while maintaining production schedules that exceeded pre-war output by factors approaching 3-to-1. German industrial collapse had become apparent through intelligence reports describing factory closures, transportation breakdowns, and resource shortages that crippled military production. Allied bombing campaigns had reduced German capacity to levels insufficient for sustained military operations, creating strategic vulnerabilities that tactical excellence could not address. By war's end, American industrial statistics would document productive achievements that exceeded German totals by margins approaching 2-to-1 across all categories of military equipment. The United States produced 88,000 tanks and tank destroyers, while Germany manufactured fewer than 46,000 armored vehicles of all types. Detroit automotive plants had been converted to military production through engineering programs that demonstrated American industrial flexibility unavailable to European manufacturers. Assembly line techniques developed for civilian automobile production adapted readily to tank destroyer manufacturing, creating productive efficiencies that German workshop methods could not match. Female workers comprised nearly half of American industrial workforce by 1944, their contributions essential for maintaining production levels necessary to support global military operations. Clara represented millions of women whose efforts translated democratic values into productive capacity that overwhelmed totalitarian military systems. German refusal to mobilize female workers fully until late 1944 reflected ideological constraints that limited productive capacity during critical periods. Nazi doctrine emphasized traditional gender roles that prevented efficient utilization of available labor resources, creating strategic disadvantages that contributed to military defeat. American Lend-Lease programs provided military equipment to allied nations while maintaining sufficient production for domestic military requirements. This dual capability demonstrated industrial capacity that exceeded German understanding of possible productive achievement, creating strategic advantages that influenced global conflict outcomes. Factory workers across American industrial centers understood their participation in moral crusade against fascist tyranny. Each completed tank destroyer represented democracy's response to totalitarian aggression, translating American values into mechanical systems capable of defeating enemies who threatened global freedom. Production statistics documented achievements that would influence post-war economic development. American industrial capacity had expanded beyond pre-war levels, while European manufacturing suffered destruction that would require decades for reconstruction. Victory created economic advantages that would shape global development for generations. Clara pressed her palm against warm steel of another completed Hellcat, thinking of unknown soldiers who would drive her work into battle against enemies who had underestimated American productive determination. Her contribution joined millions of similar efforts that collectively created strategic advantages no enemy could overcome. She whispered words that captured American industrial philosophy. Steel is our answer to their terror, production, our response to their aggression. Decades later, the M18 Hellcat occupied place of honor in tank museums where children climbed across tracks that had once thundered through European battlefields. Plaques describe technical specifications and combat achievements, but static displays could not convey the mechanical violence that had characterized its operational service during World War II. Sergeant Charles B. Hall had returned to civilian life in 1946, his wartime experiences providing stories that would entertain grandchildren who could not comprehend warfare's intensity. His Hellcat crew had survived combat operations that destroyed 60% of American tank destroyer units, their survival reflecting tactical skill and mechanical reliability working in combination. Karl-Heinz Prinz surrendered to American forces in May 1945. His final months of military service characterized by retreat operations that demonstrated German industrial collapse more clearly than any intelligence report. His Panzer IV had been abandoned due to fuel shortages rather than battle damage, symbolizing strategic defeat through resource exhaustion, rather than tactical failure. Post-war, interviews with German tank crews revealed psychological impact of facing American industrial superiority that rendered traditional military virtues irrelevant. Soldiers trained in tactical excellence discovered that skill could not overcome productive advantages that enabled enemies to replace losses faster than German forces could inflict casualties. Hellcat production statistics documented American achievement that exceeded German understanding of possible industrial capacity. Final production totals reached 2,647 vehicles manufactured during 30-month production period, representing productive efficiency that German industry could not approach despite mobilization efforts, including forced labor from occupied territories. The tank destroyer's kill ratio of 2.3 to 1 represented highest effectiveness achieved by any American armored vehicle during World War II. This performance reflected tactical doctrine that emphasized mobility over armor protection, confirming American strategic understanding that speed provided better survival rates than static defensive strength. General Patton died in automobile accident during December 1945. His tactical innovations preserved in military doctrine that would influence armored warfare development throughout Cold War period. His emphasis on mobility warfare demonstrated principles that remained relevant despite technological advances that transformed battlefield capabilities. Museum visitors studied technical displays describing Wright Continental radial engines, transmission systems, and 76mm main guns, but specifications could not convey psychological impact of mechanical systems that had moved faster than enemies thought possible while delivering accurate fires at maximum range. American industrial achievement during World War II created economic foundation for post-war prosperity that would influence global development for remainder of 20th century. Victory demonstrated productive capacity that enabled democratic nations to overwhelm totalitarian military systems through sustained industrial effort rather than tactical brilliance. The legacy extended beyond military applications to civilian technologies that transformed American society during post-war decades. Manufacturing techniques developed for military production adapted readily to consumer goods, creating economic abundance that validated democratic values against totalitarian alternatives. Freedom had rolled forward at 55 miles per hour across European battlefields, and tyranny could not match its mechanical determination or productive foundation. If you enjoyed the story, I handpicked this next story that you will enjoy. Please don't miss this one. Click here to watch it.